I'm not giving an answer to the previous quiz. If I can talk to this, there will be suspense. What are the various types of tests you have to catch? You catch the design errors. How do you catch design errors? By verification. We spoke about verification in the last video. Manufacturing errors with testing. We spoke about difference between verification and testing in the last video. External or environmental disturbance. Again, there is explicit testing, there is implicit testing. The disturbance are random in nature, right? The fluctuations in power supply, any radiation effect, EMI. I hope you all know what is EMI, right? Induction, automatic induction. Wear out. We spoke about wearing out, stress, right? So you do reliability testing. Let's say you you fast for 3 days, don't eat anything, you don't drink water. Wear out, right? Or you don't sleep for 3 days. You fly abroad, you have a jet lag, right? So there is a wear out. That's how you test how reliable you are. What is the meaning of reliability in English? Pause the video, think. Okay, let's go to next. What are the different types of tests we can do? So based on the purpose of test, we spoke about the purpose of test in the previous slide. So let's see how we can do that. Production test. This is for volume production. We are making 10 billion parts. So to test each and every part, as we saw in the last video, last class. So we need for volume production, we need something called production test. That's called production. In movies, they call producer, we say, right? What is a producer? You'll see this term in verification course also. Producer and consumer. What is a producer? Think about it. Right? It's a simple English. Production. In movies, in journalism, everywhere, in electronics, computer science, everywhere there's a production. Where there's a system, there's a production. There's a process, there's a production. We're producing kids. In the olden days, there are 10 kids, 15 kids in a family, right? My father has 8 siblings. My mom has whatever siblings, right? So big family is 2 generations before. So they produce kids left and right. Okay, let's move forward. Characterization. What do you mean by characterization? Let's think. What is a character? Can you think? What is a character? This person's character is not good. Or is it good? You get a conduct and character certificate you get in a school, right? Character certificate or conduct certificate. What is that? Can you apply that concept to IC design? Think about it. Reliability test. We spoke about reliability. How reliable it is. How reliable am I as a faculty? Right? I'm reliable as a freelancer in industry. Am I reliable? I know I'm not reliable, right? Because I don't decide, right? If I decide I'm reliable, I don't know how to decide, right? And I don't know anything. So how am I? I'm not reliable. So I have defects, right? I told you that's my weakness. We have defects and lifetime prediction. Lifetime prediction, can I do? How long I will live? So, but we need to predict for electronic products. We need to predict, that's a reliability test. How many years? Phone typically, how long it work? Pause the video. Ideally, interactive class would have helped here. Pause the video and write down and post in the classroom. How many years you change your phone? How many years you change your TV? How many change your bike? How many years you change your washing machine? How many years you change your car? How many years you change your house? I mean, building a new house, not rental house, right? So that is reliability. I can keep giving examples. Let's stop. Diagnosis. What is diagnosis? Important. In medical, what is diagnosis? I'm diagnosed with corona. I'm diagnosed with typhoid. What does it mean? Can you think about it? The answer is in the slide. Pause the video. Take notes and think about it. Thank you. Let's resume. Based on the stage of the test, we saw what is the purpose of the test we saw. Based on the stage of the test. This is wafer test, test on wafer, right? So what is the wafer test? We test on the wafer. Package, we saw what is a die. There's a wafer and die test of this similar. Package test. So what is the packaged part? You can test on the packaged part. System test, which is board level test on the system, complete system. You can do many tests, function test, install, history OL, any test we can do. Based on the technique, how do you classify them? DC parameters. Here I have a pause the video for a moment. You want to know what is VOH, VOL, VAH and VIL? I'm not going to train you on all those things. You should pick up a data sheet from Texas Instruments or National Semiconductors. Look at what is 74LS04. What is 74LS00? What is 74LS74? Look at any data sheet or 8085 data sheet, whatever you want. Look at what is a DC parameter, what is the AC parameter. Self-study. Right? You should do this as a prerequisite for the course. You should know what are there. I'm sure you have done basic analog and digital electronics. AC parameter test. Again, yeah, you should know what is AC parameter. Then let's come back and tell me what is DC parameter, AC parameter. Then we'll talk about test. Boolean test for logic functionality. At low speed, you can test the test, you can generate test patterns to test patterns and applying the test, the type of test we saw before, right? Delay test. At high frequencies, there are a lot of delays will happen. Delays will scale sometimes with various parameters like time and process. So with respect to the frequency dependency, we have to test, delay test we have to do. Functional test, the function is working correctly or not, but various conditions. IDDQ test, please write a note. It's an advanced topic. IDDQ is type of leakage current test. Quiescent power supply. You would have noticed what is the biasing? Quiescent power supply, I'm sure you would have read in a lot. Op amp, biasing, right? If you know that, there's a way to test that. But that's advanced concept, we will not touch it. Low voltage test. What happens if your chip is operated lower than the VDD? It's rated at 5 volts. What is the chip running at 3 volts or 1.2 volts? What happens? How does it behave? So you have to test that, right? So your test is very, so I'm going to test you in your exams. Right? I told you it's an open book exam. You are saved, right? But yeah, I know how to play mind games. Follow me on LinkedIn. Yeah, it depends. I'll evaluate you with 3 more months to go. So based on your knowledge, same question, but I can tweak a little bit. I can change why to what. You have written something. You give me your question paper, right? Let's say you give 40 questions, I'll give 20 questions from there. I'll change one word somewhere. You have to, I'll make you think, right? Concepts, application of concepts, experiment, experience. That's our thing. I don't know anything, you know everything. I don't decide, you decide, right? You decide your grades. You decide absolute grading. You discuss everything, right? So you know what to do. So characterization test. Again, I'll keep this video short. There's this little bit detail and yeah, the characterization tests are not applied for all the parts. Instead, it's support for small type of ICs to verify through the characterization test. You should know what is characterization and characteristics. The test cost and test time are not concerns, right? So what is the purpose? You verify the functionality is same as the design, confirm the specification or what are the specifications under different test conditions, under a different process, different voltage, different temperature. What are how does it meet the specifications? Does it meet or doesn't meet? Now, what are the specifications? What is your frequency of operation, which is speed? VOH, VOL, we spoke about it. I'll not talk, you should know what is it. Rise time, fall time, you know it, I don't know. What are the different conditions we spoke about? Voltage, temperature, process, right, with the material, there are various conditions. So you have to have a test program for test. So the characterization is required to determine the pass and fail. Characterization typically pass and fail may not be needed. There's some interesting knowledge because we have to verify the parameters, but still it will be good to have. Because some of the characterization you have to port it to production test under certain extreme conditions, right? So better you have a pass and fail signature. Okay, this is interesting. This is a wafer. Okay, the green dots, what you see, I don't know, I can zoom here. PPT will die. Let me see if I can show anything. I don't see anything here. Okay, so there's a big one is wafer. You can zoom in the slides. It's in the classroom. There's a wafer and small green dots are the die. And these things are various, let's say here, right? There are various issues what you have, the test failures. So there are different failures, so there are multi-site, single-site. Single-site is checking one wafer at a time, right? Multi-site is checking multiple dies at a time simultaneously, right? So here there are a lot of failures. You can see there may be issue because of the wafer. that wafer, this produces wafer. So you don't package all these dies, right? So single site, interesting is a possible wafer issues again. There are a lot of failures in a region. So these are already happening on the periphery, right? And the bone radius happening. Yeah, there could be a probing issue or contact issues maybe there, or a real wave. It could be any reason, right? You go to a doctor, you give a paracetamol first, right? Or you give take a blood test, then you say you take a scan. So the debugging keeps changing, right? Diagnosis keeps changing. So it could be some issue. You start somewhere, you assume something, experiment and experience, same thing, right? That's how the debug happens. So what is a wafer map? Yeah, that is you can read on your own. So basically what we do is the concept, I'll give you the concept, right? I'll skip the slide. I've got another 5 minutes, we'll conclude this video, not more than 15 minutes, right? So you have to, there are different bins, there are different buckets. I wrote about financial planning, right? You spend money, how do you spend your money on average in a month? Food, right? Your laundry, entertainment, medicine, travel, partying is entertainment, medicine is doctors. I mean, five or six buckets, right? Miscellaneous, you put it, or rest of the things, right? Or you save some money for a habit of saving, investing, you save some money, you spend money, right? You earn, you save, you spend, right? And maybe you donate to a philanthropist, right? So there are different bins, different buckets, and we call bins in testing. There are different buckets you have, and you put different parts, all the passing parts in one particular bucket. All the failing functional test, putting in one bucket. When failing low VDD test, you put in a third bucket. Failing the DC test, you put another bucket, and so on. Create different buckets and you classify, right? And wafer map, something what we saw previously. Let's see if we can go back to the slide. I'm not able to go back. So wafer map is used for whatever. You can go back to the previous slide and see I'm not able to move on to backwards. So this is something called smooth plot. Yeah, I don't know why it's called smooth, but it's basically frequency versus voltage. Because y-axis is voltage and x-axis is frequency. So low speed, everything is passing, right? As the frequency increases, it fails. So I want you to think why the frequency increases, that is given design will fail, right? As you can see, for a given frequency, say this particular frequency, whatever this particular frequency, it keeps failing. As you increase the voltage, it starts passing. Why? So think, the two things I want you to think. Understand this chart very properly. Forget about why it's called smooth. It's called smooth plot. That's what you get from your ATE testing. We will talk about what is ATE very soon. So as the frequency increases, the test starts failing. As a for given frequency, for given voltage, as the frequency increases, the test starts failing. For given voltage, for given frequency, as the voltage increases, the test starts passing. Ignore this particular condition. It is very unstable feature. Right? So why it does happen? Please pause the video and think. Discuss in the classroom. Post your answers in the classroom. Reliability test. So quickly let me cover. Burn-in test. Right? Very expensive. You have machines like this. You know what is an oven? Microwave oven. What happens in a microwave oven? Think. Pause the video and think. Similar concept. There's an oven in the semiconductor industry. Put your chip or entire system in the oven. Something called infant mortality. What is infant? You all know English, right? You're 20-year-old minimum. What is infant? What is mortality? What is infant mortality? Pause the video. Or early life failure. In olden days, people used to die very young, right? It's very rare these days. So why? What happened? Please think. When high temperature and high voltage test you conduct, that's a burn-in test. STOL, what we call, there's a reliability test. It's very expensive. There are a lot of tools for that. A lot of hardware for that. There is something called accelerated. Now you can. How do you accelerate your lifetime? Can you accelerate in a time? Let's say you have a time machine. Can you go 50 years forward? That is that, right? You burn the chip until it is dead. Please don't do that. I'm just joking. Right? If you have an old phone, you take out the chip and put it in an oven, not micro oven. I'll take you to industry somewhere if you are interested. Go and see those things. Right? So only you don't do it for all the parts. Do it only for sample license. Okay. There's a bathtub. So how do you assess the infant mortality? A normal lifetime period and wear out period. There's something about. I'll stop with this slide. Right. We're about 15 minutes. I give you thinking time, so it's about 20 minutes or 25 minutes. So we'll have one more video later. I'll stop with this slide. So failure rate resembles a bathtub. Right? It's a bathtub. So it fails early in the life, right? Normal life, and as it gets old, it fails. So there's a lot of failure in the beginning, life in the lifetime of the product. Product is not stable. When it's stable, it's everything. It's very process. There's no failure. But as it wears out, it gets old. Same thing as human. Right? People can die as the womb itself, kids die, get aborted, right? When young guys, there's a lot of risk at the time of birth to both the mother and the child. You all know, right? Rebirth for the mother, right? So in fact, what it is that, but when you get stable, yeah, there's a risk. If you walk in the road, there's a risk. If you sit inside the house, the fan will fall on my head. So you have to walk on the road. You have to live inside the house. You have to go to play. You cannot. Oh, I'm playing a cricket. The ball will hit my eyes. I lose my. There are people who have died while playing cricket. Naturally, can't particularly lost his eye. There's one of the cricketer who died while playing cricket. I forgot the name. He didn't wear a helmet. He was like fitting in a very short leg or some location. Ball hit him. He died. Right? Raman Lamba, if I believe. I forgot. Right? So it's very dangerous. Right? People have become disabled. Sports. Right? I talk to you often and tell you stories. So we'll stop the class here. We'll continue the next class with what is the DO2 testing. Okay. Thank you. All the best.